All right, welcome to part 2 of rational functions. I put a little picture up in the corner here just so that you have a face to go with the voice that you hear all the time throughout the chapter. That's Daddy and I after a morning run. I just thought nice little picture to share with you. All right, let's go ahead and dive right in. Since this is day 2, some of this should be familiar with you. So big thing to do is remember to just go down through your list here, and that'll help you give a good indication of what your graph is going to look like. So as you can see, since it's already factored and you don't have any factors in the numerator, they're also in the denominator, there are not going to be any holes. The x-intercept, remember that you want to set the numerator equal to 0 and solve, and it looks like we're going to have an x-intercept at 1/2 and an x-intercept at -3. If I want to find the y-intercept, remember I have to plug 0 in for x, and if I plug in 0 for x in the numerator, I get a -1 times a 3 over a 2 times a -3, yielding -3 over -6, or 1/2. For my vertical asymptotes, remember set the denominator equal to 0 and solve. So it looks like we have one at x equal to -2 and x equal to +3. And then the horizontal asymptote reminder is based upon the degrees. And if I look at the situation that we have here, if I FOIL out the numerator, I have an x squared. In fact, I'll have a 2x squared to lead. And if I FOIL out the denominator, I'm going to have a 1x squared. So anytime the degree of the numerator is equal to the degree of the denominator, remember that it is basically based upon your leading coefficients being divided by one another. So therefore, we have a horizontal asymptote occurring at y equal to 2. All right. Let's now take a look at what our picture is going to look like. So if I have my asymptotes at -2, I have another one at 3, I got my horizontal asymptote at y equal to 2. Reminder that you can cross horizontal asymptotes, you don't cross vertical asymptotes. All right, it looks like I have an x-intercept occurring at 1/2. I have an x-intercept also occurring at -3. All right, so that kind of helps me get some of my points. I also have a y-intercept occurring at a 1/2 as well. All right, so from here we said to just kind of plug in some numbers. Since I already have 1 point all the way to the left of this asymptote, I'm just going to plug in a -4 in and see if I can find one more point. And if I plug in a -4, that gives me what? -9 times a -1 in the numerator, and then -2 times a -7, so 9 over 14. So I have a 9/14, which is less than 1. Okay, and so now it looks like I have a curve occurring like this, and remember it's going to follow along the asymptote. All right, in between the two asymptotes, I already have 2 points, so maybe I just plug in a -1, and if I plug in a -1, it looks like I get a -3 times a 2 over a 1 times a -4, and it looks like that's -6 over -4, or 3/2, 1/2, which is right here. I'll plug in one more point. I'll plug in 2. If I plug in 2, I get 4 minus 1, which is 3, times 2 plus 3, which is 5, 4 from 2 plus 2, and then -1, giving me 15 over -4, which is very close to -4. It's -3 3/4, and that'd be right about here. So it looks as though I have a graph that is coming in and do a nice little S-curve here. Okay, and then now I just have to keep going and do the other side of the asymptote. So if I plug in a 4, I've got a 7 times a 7 over a 6 times a 1, 49 divided by 6, which is what, a little over 8. So I've got a point all the way up here. I can plug in 5, which gives me 9 times 8 all over a 7 times 2. So 72 divided by 14. Which is a little over 5. So I've got a point here, and so now it looks like my curve is coming down. It's just not coming as tightly close to the asymptotes as it would on some of the other graphs. All right, let's go ahead and take a look at our second example. All right, in this one, again, going through, if I want to figure out holes, the first thing I'm going to think about doing is factoring this. And so I've got an x minus 4 and an x minus 1. I've got an x plus 1 and an x plus 1. All right, so it doesn't look like I have any holes to worry about. X-intercept, set the numerator equal to 0, and it looks like I would get a positive 4 and a positive 1. My y-intercept, well, if I plug in 0, 0, 0, and 0, I'm left with 4 over 1, which is just 4. My vertical asymptotes are going to be at x equal to a negative 1 by setting these two parentheses equal to 0. And horizontal asymptotes, well, since my degrees are the same, it's 1 divided by 1, so it looks like I've got y equal to 1. So let's go ahead and graph that. So I've got y equal to 1 for my horizontal asymptote. I've got x equal to negative 1 for my vertical asymptote. I've got a y-intercept over here at 4. I've got a x-intercept occurring at a 4 and at a 1. That gives me an idea that this graph is probably going to come down, cross, come back up, and then run along the bottom side of this horizontal asymptote. Okay, and then on the other side, I should just plug in, negative 2 and negative 3 and see if I can get some points. So negative 2 would give me a negative 6 times a negative 3 all over a negative 1 times a negative 1, which gives me positive 18, so that's not even on the graph. And if I do one more time with a negative 3, negative 3 would give me negative 7 times a negative 4 all over a negative 2 times a negative 2, giving me, positive 7, so 3, 7, so it looks like the first point of the graph is going to occur here, so my graph is coming down, awful wide, and then eventually coming down to the horizontal asymptote. All right, so here's another example like one of the ones from yesterday where you do have a graph crossing the horizontal asymptote. All right, on to page 2. All right, so part of the reason why I showed you the picture at the beginning is your trivia question for the day. If you want to put the name up at the top corner is, what's the name of my dog? If you can tell me what that is, you can get your extra credit. All right, I'm going to skip example 3, and I'll give your teachers an opportunity to work on that one with you in class. We're going to go directly to example number 4. All right, so number 4, first thing I'm going to do is I am going to factor this, and I've got x minus 2, x plus 2 from the difference of two squares. I'm going to factor out a negative x squared. I always like to have a leading coefficient with my quadratics that is positive, giving me an x squared minus x minus 6, and this can now be factored. So I've got an x minus 2 times an x plus 2 all over a negative x squared times an x minus 3 times an x plus 2. So now we see that we are going to have a hole occurring at negative 2. Okay, so we've got vertical asymptotes occurring at 0 and 3. So x equals 0, x equals 3. So here's one of our vertical asymptotes. Here's our second vertical asymptote. All right, x-intercepts. Well, if I set the numerator equal to 0, I've got x equal to 2. Y-intercepts, if I plug in a 0, I'm going to get negative 4 divided by 0, so that means that there must not be any. And if we think about it, notice that we have a vertical asymptote at x equal to 0, and it's not going to cross that line, so therefore there's no y-intercept. And then horizontal asymptote, reminder on this one, we should end up with a y equal to 0, and the reason for that one is because remember that the degree of the numerator is less than the degree of the denominator, giving us y equal to 0 for our horizontal asymptote. All right, we're going to go ahead and graph this and take a look at what this looks like. All right, so plug in some numbers, say like negative 1, so that we can do the left side of this first asymptote. And if we plug in a negative 1, it looks like we'll get a negative 3, negative 1, negative 2, plus 6, it looks like 4, so we're going to get a negative 3/4. Okay, and if we plug in a negative 2, reminder that if you plug in the negative 2 into the numerator, you're going to get 0, and the reason for that is because that's where our hole is going to occur. Okay, so it looks as though our graph is coming up. It's going to pass through there, it's going to have a hole, and it's going to run right along this asymptote. Okay, so big reminder that we have our hole occurring at negative 2. All right, if we take a look at in between, so I'm going to plug in a 1, and if we plug in 1, we get negative 3, and if we plug in 1, it looks like we get a 6, so we have a negative 1/2. And if we plug in a 2, looks like we're going to get a 0. So it's going to cross the asymptote here, which tells me that looks like our graph is coming down, passing through these 2 points and doing a little S-curve like this. Okay, and then we have one more to do, and if we plug in 4, so that we get our curve on this side of the asymptote, plug in 4, you get 16 minus 4, which is 12. And then our denominator, if you need to, pause the video, plug in, and figure out what your x value is from the denominator. You get negative 96. This can be simplified down to negative 1/8, which is negative 1.25. Okay, so that's very, very, very close to the x-axis. And if we plug in 5, we're going to get even a smaller number. And so it looks as though our graph is going this way. So we've got a graph below the x-axis all the way to the left over here, passing through our hole. We've got an S-curve in between our asymptotes, and then we've got another curve on the other side. All right. Again, as always, come with questions. There is an example here that you can do with your teacher in class as well.